everyone, I'm Tanushka and we team Java Bean Cafe, and our project is a coffee shop management system built for CS151. Our goal was to create a realistic simulation of a coffee shop using strong object-oriented principles like abstraction, inheritance, polymorphism, and encapsulation. The system runs entirely from one umbrella interface that connects both customer mode and barista mode. Customers can view menus, place orders, earn loyalty points, while baristas can clock in, complete orders, and track performance. Throughout the project, we focused on modularity, input validation, and error handling using custom exception classes. So now, Shresh will explain the foundation of our design.
Hello everyone, I am Shreys and I explain the person customer classes I implemented, demonstrating key OOP concepts like abstraction, inheritance, and validation. Let's go over the person.java file first. I declared person as an abstract class with static instance counter and 100% limit. I used protected fields for name and phone, so subclasses can access them directly. For the constructor validation, I created a constructor that checks instance limits, sanitizes input by handling nulls and trimming white space. Then increments counter after successful validation. For phone number formatting, I automatically formats phone numbers by extracting digits and formatting as triple x dash triple x dash 4x for 10 digits or triple x dash 4x for 7 digits. For phone validation, I use regex patterns to validate phone numbers in either 10-digit format or triple x dash 4x format. For my abstract method, the greet method, I require each subclass to implement its own version while enforcing consistent interface. For getName and getPhone methods, these have null safety to prevent crashes while accessing person data. The setter methods, setName and setPhone, that include validation and formatting, ensuring data integrity when updating person information. The toString method here um, uses string builder for efficient string concatenation and character by character building for security. The equals by name and equals by phone methods compare persons by name and phone with the flexible matching, ignoring case and white space. The normalized phone method extracts only digits from phone number for consistent comparison and storage. So I also have a few static helper methods: get instance count and get remaining capacity, provide access to instance tracking information. I'll go over customer dot Java now. Okay, I don't know what's not opening. Yeah, customer dot Java now. So for customer Java, customer extends person inheriting all functionality while adding loyalty points and separate instance counting. The in the constructor calls parent constructor first using super and then initializes customer specific fields and enforces customer instance limit. The greet method implementation here implements the abstract greet method with the personalized welcome message, hello, name, comma, welcome to Java Beans Cafe. I also have a loyalty points management. I have add points, redeem points, I have get points, and I also have has enough points. These methods are used for validation to prevent negative values and over redemption. I also have like something that merges the points. So merge loyalty method allows combining loyalty accounts for family accounts or account consolidation. This has not been implemented in our project, but this is something we had written and had a system design when we were discussing how to make the project, and this is something we would want to implement in the future. Now let's go down to the toString method. This extends parents to string by adding loyalty points, information using string builder for efficient string building. Also, customer equal customers method compares customers by both name and phone using inherited comparison methods. The is valid name method and is valid phone provide validation logic that can be used throughout the application without creating instances. The static helper methods I have are get instance count and get remaining capacity and they provide access to customer specific instance tracking. Now let's go over the testing file I created. This is not a JUnit test file, but it's still a testing file I had created just to test if the instance created after like 100 instance, the 101 instance, if it's being created or if it's showing an error. Okay, so let's go over the main method first. So this sets up comprehensive test suite that verifies all classes properly, enforcing their 100 instance limits without detailed reporting. Then I have the customer instance limit method. This creates exactly 100 customers and verifies count after each creation, then attempts 101st to confirm proper exception handling. I also have one barista test method here. What it does, it creates 100 baristas with different shifts and IDs, verifies counting, then tests 101st instance rejection. And then I also have one for menu item instance testing. What it does is it creates 100 menu items with various categories and prices, verifies counting, then tests 101st instance rejection.
Hi, I'm Thomas, and I worked on the barista class and the billable interface, and I also made the UML, which I will be explaining in this part of the video. We're going to start with the billable interface. It's the contract for anything you can sell. The interface defines 5 core methods. We have calculate total, which returns a double total for a given quantity. Implementations can include discounts and more, but calling code only cares about the numeric total. Then we have string get item name and get description. These are both simple string getters that return display and receipts. Then we have get unit price, which returns the base price per product as a double. And then we have is available, which is a Boolean that flags whether that item can be ordered. Why an interface? The rest of the system, orders, and other things, only calls these methods. It doesn't need to know whether the object is a menu item, a special bundle, or a promotional billable wrapper. It doesn't matter. It keeps code maintainable, and you can add a new product type, you can maintain it, you can switch it up just by interacting with this interface, which makes everything very easy. Let's take, for example, in our code, menuitem.java implements billable. Menu item also stores name, description, price, and available fields. This guarantees consistent pricing behavior across the whole application/program. Now let's move on to the barista class. This class models an employee and handles the real-world actions a barista takes. Key fields might include name, phone, employee ID, shift, a Boolean is clocked in, orders completed. We have 2 static fields, instance count, and max baristas, which is set to 100. The important methods in here are make order. This is the core of the whole logic of this class. It first validates the order. If it's not null, then checks is clocked in. If not clocked in, it prints a message and aborts. If clocked in, it calls order.setStatus complete, and it increments orders completed, as you can see here. And then it logs the completion with this print line. This protects the program and system from invalid state transitions. Orders can't be completed by off-shift staff. Then we have clock in. Clock in sets is clocked in equals true and prints the shift's confirmation. Then we have the reverse, clock out. When an employee clocks out, it has logic and it prints that clock out message as well. This class also enforces input validation on setters. SetPhone, as you can see here, uses the regex to force a 10-digit phone number. The user can only input a 10-digit phone number or else an illegal argument exception is thrown and it prints this message right here. SetShift also rejects null or empty strings. These checks reduce bugs caused by bad data coming in from the users. And I forgot to mention the simple greeting method that we have. A simple print line that has a welcome name and introduces your barista and their shift. Now I'd like to talk about the design problem and why I chose this solution. And I think the biggest problem I had was implementing this order logic that you see right here. We had 2 obvious choices. To put completion logic in order, so that order self-handles everything, or we can put it in barista. Initially, we put some of the logic in order, but that blurred responsibilities. Order started handling respons Order started handling actor-specific rules, like checking clocking in, which isn't an order's concern. That leads to tangled code and harder tests down the road. The solution that I chose was to move that action, that block of code, into Barista. Why did I do that? Well, it reflects real-world responsibilities, right? A person completes the order. A person does, not the order completes the order. Not the item completes the order, a person completes the order. This keeps order as a stakeholder and invoice generator in a way, and Barista as that actor that changes that state. And what's the result? They're clearer responsibilities, simpler unit tests, and fewer cross-cutting condition checks. Let's say we later introduce a manager, for example. We can reuse this pattern without having to change order. Now, let's go through the UML top to bottom. At the top is the abstract person class. It contains the common fields name and phone, and a few methods for validation, such as is phone valid, normalized phone, etc. Making person an abstract class avoids duplication between customer and barista because they both inherit. They both extend this. On the left, customer extends person and adds loyalty points, and methods like add points, redeem points, merge loyalty. Customers own orders conceptually. Orders has a customer reference, meaning each order belongs to exactly one customer. Then in the center is the order, which is the transaction object. It contains a static counter, a few lists, quantity, status, and some of the methods include add item, get total, set status, and more. Order is a composition of items. It contains them, but does not implement billing logic beyond calling calculate total that I explained earlier on the billable objects inside it. Then on the right, the one I created, is barista, which extends person, as you can see with the arrow here. The UML label, the UML label also processes barista to orders, and it shows the association here as well. Baristas manipulate order state, but do not own orders. One barista can complete many orders, and each order is handled by one barista at completion. Then on the bottom left, we have menu item, which implements billable, which is the dashed line right here. Its responsibilities store name, price, description, and other data. It implements calculate total and provides updated price or availability. This keeps pricing modular and testable. Menu item is an important class for organization and keeping code extremely clean. And on the bottom right, we have coffee shop. This is the application manager. This is the core of our entire program and where we run the entire thing. Things like static menu and orders. We have main, menu loop, and helper methods like place order, view menu. And again, it coordinates creation and life cycles, but relies on the other classes to do the actual real work. To summarize, billable ensures consistent billing. Menu item implements that contract. Order holds state and delegates billing to billable objects. And barista is the actor that changes order state while enforcing business rules like clocking in and instance limits, like the barista is capped at 100. So we don't hire more than 100 baristas at a small coffee shop. Now I'll hand it off to Anand, who will explain how menu item, the class that I mentioned previously, and our exception handling make the program more robust. Thank you.
Hello, my name's Anon. I'm in charge of this class, menu item Java, and the making validations and exception handling, which are these other three exception handling classes as well. Let's start from the top. So yeah, it's in the package coffee shop, and this implements billable, which means they must provide, the methods defined in that interface, calc total, item name, a couple more that we'll see as we go down. Here is our constructors. So this one above here is the main constructor. It's a three-argument constructor and checks the capacity and then uses the validated setters to rule staying in one place. This one is an additional one that I had to add later. It just has two arguments. This is more of a convenience factor. Coffee shop.java only worked with this one, so I had to add it in later. But it pretty much routes to the first. Here we have some setters with some quick checks. So just to go through these real quick, they'll throw an exception, and we can go over that real quick before we go in depth. We have three different exceptions based on different stuff that can happen. This is a pretty much general purpose one, invalid order exception. And this is used in most things if, you're calling something that's invalid. This is a more specific one. This is specifically for the max items. If you're ever adding items beyond the max, then you can call this order limit exceed exception, where you can't add more than, however max items. I think for this it's 100, but you can set it to whatever. And this one is a menu item not found exception, so look for the menus items. And if there's like, four things in the menu and you call the fifth or the zeroth or whatever, you can call this and say menu item not found. So back to the setters, we can use these. So for set name, these all have some validation built into them. This first one, it's if the name is null or it's blank, then you can throw an invalid order exception. And saying the name can be empty. And set description, this is pretty much identical to this one, but just for descriptions, same thing. If it's null or if it's blank, then you send the same exception with a different text. Oh, also, these both use the trim just to keep the input clean, because who knows what the user is going to input. So if there's any extra spaces, we want to get rid of that and keep the things going. Set price is pretty similar in concept, except instead of checking if it's null or blank, it'll be for negatives. And because we can't have negatives in the prices, so if there's a negative price, then this will throw an exception. If not, then it'll normalize to two decimals. Here we got some tiny mutators, helpers. This is flips the flag of availability if something's sold out. This is a quick helper to preview a discounted item price. And oh, here's a core logic piece. These are what are taken from billable. This one is the biggest one. It's has two inherent checkers here, like validations. This first one, invalid order exception, if the quantity is negative, because we can't have that. And once again, if it doesn't exist or not available, it'll throw an invalid order exception saying item is unavailable. And then if it passes these two, it'll, validate, after validating the quantity and availability, it'll do the math multiplying price times quantity, and then once again standardize to dollars and cents, two decimals. Here are the other stuff from billables, just overridden for this class. Here we have two static helpers. These came in handy along with the idea of why we have exception handlers. When something goes wrong in like something that has so many moving parts like this, like you see all these classes, it's hard to know what went wrong when it just returns null or when it just doesn't work. So with stuff like this, it'll throw menu not found exception in this case, or in this case, based on whichever, statement it falls into, this will throw invalid order exception, or if the addition will be more than the max, this will throw an order limit exceed exception. And these all kind of work to make debugging a little bit easier. Here we got an override for toString, just to, make stuff nicer in printing. It'll take the name, price, and availability, and then it'll pretty output when you get an item. Here we have, oh, this one. It compares to objects, and it'll basically just tell you if they're the same when the key fields are all matched. So when two menu items counts or have the same price, availability, name, description, then this will return, true, the bool. And this last part here, because we're working with, hash maps and hash sets, I had to override the default hash code method so that they work correctly. Basically, what this is doing is it's giving each item a unique numeric like ID or fingerprint based on these name, description, price, availability. And that way, if two identical items are there, they're treated as, the same thing instead of duplicates, which makes the stuff work out a little bit better. And that's about it for here. In general, the ideology behind having all these exception handlers are, just to make debugging a simpler process instead of having to comb through every single line of code of all of these. It'll kind of point you to where something went wrong. So that's it for my section. Now, Tanishka will show you how all these parts come together inside Coffee Shop and how the system runs.
Okay, so thank you, Nan. And now I'm gonna explain the order and coffee shop classes I implemented. These handle like the core business logic and user interfaces that brings our coffee shop system together. So first I'm gonna go over the order.java file. So the order class models the real world process of placing and completing a coffee order. So each order object is linked to customers is linked to a customer and tracks several things. A unique order ID generated by the next ID method using a static counter. So a list of items and their quantities that you can see. So the order status usually is like pending or complete. We used two array lists here, one for the items and one for the quantities to maintain a one-to-one relationship between what was ordered and how much of each item. So the add item method handles the adding new items to an order, checking that the quantity is greater than zero, and the maximum number of items doesn't exceed our limit, and that is 10. So next, the get total method is where we perform the price calculations. It loops through each menu item, calls the calculate total method from the billable interface, and adds everything together to produce a precisely rounded total. And finally, the toString method is overridden to display order details in a neat format, showing the order ID, status, total cost, and the customer's information. So basically, this string representation is what you see on your screen when you view all orders inside coffeeshop.java. Okay, so now I'm gonna go over the second file, which is the coffeeshop.java. So the as you can see, the static collection of menu, orders, barista, and a scanner for application wide with 100 order limit is here. First, we initialize system by loading menu and baristas, and then start the main menu loop. Then we get like the navigation system, allowing users to choose between customer mode, barista mode, or exit the application. Then we have here the customer interfaces with the options to view menu, place order, view existing order, or return to the main menu. The barista interface requires the barista's selection first, then provides the clock in, clock out, view order, and all of the other options. And then we have the select barista method here, which displays available baristas, handle user selection with validation, and returns the selected barista with greetings. So next we have the view all orders for barista method, which displays all orders for barista's review with empty list handling. Then the complete order method, which allows baristas to select order by ID, validate selection, and calls baristas make order method. Then we have here the preload baristas and preload menu, which basically like initializes the system with sample barista and menu items for testing. And then we have the view menu display, which displays the menu basically, and then the place order method, and so on. So here the loop allows customers to add multiple items with validation for item selection and quantities continuing until finished or the limit reaches. Next we have we calculate the total, add orders to list, and award loyalty points based on total amount and provide user feedback. Here we have the get validate name method, which uses loops to get validate the customer name using customer class validation and retry options. Then the get validate phone validates the phone number using customer class validation with user-friendly error methods and again retry options. Then again, we have here the view order methods, which displays orders using order class toString methods with empty list handling. And then in the end, we here have the exit app method, which helps you exit the application with a sweet goodbye message. Well, this completes the core business logic and user interface. Order handle calculations through the billable interfaces, while Coffee Shop brings everything together in a user-friendly interface for both customers and baristas. Thank you.
Okay, guys, now I'll show you the demo. So when I run java coffee dot dot coffee shop dot coffee shop, because it is inside the SRC, the coffee shop folder. So I have to run this. When I press enter, we go to our main dashboard. So there are three like choices here, one, two, three. If I press three, I exit. Then I'll run it again. I have now let's create something. Let's create an order. I'm a customer. Okay, let's view the menu. So this shows all the menu items and the prices very accurately. Let's try placing an order. So my name is Shrest and my phone number is 123 456 789. Okay, let's go. So hello Shrest, welcome to Java Beans Cafe. And now it's asking me to, okay, you won't be able to see it, but it's asking me to enter item number 0 to finish. Let's go for espresso. So it's two. So I've selected espresso and I want to buy for one of my friends too. So let's do two. Now it has shown that I've added the item here. Let's exit and see if it has actually been added. So 0 to finish. Now let's see if our order has been placed. Order one pending, total $6 because I ordered two $3 items. So it's total $6. My name is here, my number is here, and the loyalty points I've earned. Now let's go back to the main menu. That's four. Now let's complete the order. I'm a barista, and I am Bob Smith. So let's go to. So hi, I'm Bob Smith and I'm barista for shift. So it's evening shift. Let's try without clocking in. Let's try going over it without clocking in. So I'll view the orders. So this is the pending order. Now let me try to complete the order. So this is the order. Order number is right here. Let me try completing it without clocking in. So let's put one because that's the order number. And it shows that Bob Smith cannot complete order while being clocked out. So let me first clock in. So now I'm clocked in for the evening. Now let me view all the orders again. So order one, pending, total $6, name of the person and loyalty points. Now let me try completing an order. Okay. Now the order number is still one. So let me enter one. So order number completed by Bob Smith. Total order completed is one. Now let's see my performance. So you can see the performance of the employee like this. Now before leaving, I'll clock out. I have clocked out for today. I have completed one order. Now let's go to main menu and back to customer mode and check if the order has actually been completed. So let's go back. So it's number six. Now let's see. Okay, let's view the orders. It shows complete. So the barista has completed the order, and as soon as the barista completes the order, it is reflected here that the order has been completed. So this is our whole application. So the design challenges and problems we had and how we solved it. So for the phone number validation and formatting with various input formats, I implemented a two-step approach with a flexible input validation, accepting multiple formats and automatic formatting that extracts only digits and reformats it into consistent triple X dash triple X dash 4X format.
And the next problem that I faced was about how to handle different types of billable items flexibly while maintaining type safety. So how I did that was by implemented the billable interface patterns with list billable instead of list menu item in order class, allowing polymorphic storage and dynamic calculation through the interfaces. And the other two problems that we faced were basically about the exception handling system and the logic bug. So
So the how we solved the problem was we implemented a consistent rounding throughout the pricing system using math.round price into 100 by 100 pattern in all price calculation and setters to fix the logic bug in the bonus points. For exception handling, we created a custom exception hierarchy with invalid order exception as base, order limit exceeded exception for item limits, and menu item not found exception for missing items, each with context rich messages.
And well, that's it for our presentation. I hope you enjoy it and thank you so much.